Okay, so today we will start with chapter 5 regarding data visualization. Okay. Yeah, so for data visualization, so mostly here we are going to if you recall, chapter 3 and chapter 4, we learned about Pandas data frame and series. They are like the raw data, okay? And so from the raw data, a lot of time it's hard to find some of the information that we need. So if we can use graph and the charts, so if we come up a graph and the charts from the data frame and the series, then it may reveal, like over here says, reveal more information, like the pattern of the data and the data's trend, correlation, okay, and also anomalies that might be difficult to see, to find from the raw data alone. Yeah, so this considered as visualization, okay? And the common graph and the charts um, include the following, like a line chart. And in math, we do line a lot, okay, like a curve, all sorts of curve. Histogram, and we will see, okay, and the box plot, scattered plot, and the bar charts. So those are the and some other types of charts or graphs. Okay, so those are the common visualization representation. And in this chapter, we will also learn two new libraries regarding plotting. Okay. And in chapter 3 and chapter 4, we learned pandas. Okay. And today we will start with pandas. Pandas also provide the plotting tools so that we can also use. Okay, so besides that, in this chapter, we will learn another two library, plotting library. One is Matplotlib, and the other is CBOM. Okay, and so these two will also help us to create visualization. Okay. And like over here, said, the graph and the charts then can help us do the trend analysis, distribution, correlation, and the comparison. Okay, so all of this are going to help us to find more information about how data is distributed. Okay, so quite helpful. And regarding the Python-based plotting libraries, there are a number of other libraries, but we mainly will just discuss Matplotlib, CBOM, and also including Panda itself. It also include the plotting method. So the first is regarding plotting in pandas. Okay, and so the plotting from pandas we will also see it's more convenient, okay, because we don't need to worry about like X, Y coordinates, okay, not like the matplotlib. So that's why over here it says it provides quick and simple data visualization, okay. And for the various uh, graphs, uh, so here it lists some of it. Okay, so let's see. And the most commonly used. The first is regarding line. Okay, so line, it will provide the trend for continuous data. Okay, if you recall in math, okay, we learned various curves, so it reflect some kind of trend for the continuous data. So this is line. The second type is bar, and the bar is very helpful for comparison for different categories. So here it emphasizes comparison among different categories. We will see. The third is about histogram or box, okay? And they help to review information about how data is distributed. And the next type is scattered. So scattered is the data points themselves, okay? And it will review the data correlations, okay, and the patterns and the clusters, okay. And the next type is area. So for area, it can review the accumulation of each data category. So you can have multiple category in one plot, okay? And then it can reflect the accumulation. For bar, so this bar itself is vertical. So this is vertical. But a lot of time we also want horizontal, okay? So for horizontal bar plot, then it's bar H, okay? And there is another type called pi. So pi is data proportion. So it reviews the proportion, okay? And the other type is KDE, so kernel density estimation. So what it reviews the possibility or likelihood of some values occur in a range. So here it's likelihood in some range, okay? So this is Pandas plotting. So let's first take a look at the concept, okay, about plotting in matplotlib. But for pandas plot method, okay, even though it can provide like a line bar, histogram, okay, what we previously discussed, but over here it says it lacks some options. So here is a key point, customize the plotting canvas. Yeah, so pandas doesn't support this feature. So customize the plotting canvas and some other aspects, okay? Like here to list line, style, colors, okay? So matplotlib, so regarding this, okay, so it provides, so if you want your graph or chart, including the plotting area more complex and informative for data exploration, then you can choose matplotlib. Because matplotlib is not just regarding data frame or series. It's purely on X and Y, the coordinates. So that's why it can offer more complex and informative plotting, okay? And the matplotlib is a Python package, and it's only for 2D plotting. Okay, and here it also says it offers object-oriented approach. And this object-oriented approach, it supports to provide a plotting canvas. And in Pandas, it doesn't have such plotting canvas. And because it provides plotting canvas, later on we will also see you can also do subplots. Okay, not like in Pandas, you can only have one plot. Okay, so because it's provide plotting canvas, so you can also arrange various plotting elements on it. Okay, so it's it's complex, it's rich. Okay, compare so versus pandas plotting. But the advantage for pandas plotting is it come from the data frame or series itself. Okay, so we don't need to provide like the X, Y coordinates. Okay, but if you use matplotlib, you need to provide X, Y coordinates. And so on the textbook, it also provide this table for installation, the matplotlib. So before you can go ahead, you needed to install it, okay? And after you install, you can verify. So here it also give us a very simple script so that you can verify the installation. So to start with matplotlib, we needed to use its submodule pyplot. So the way to do it, you import matplotlib.pyplot. So the pyplot is a submodule of matplotlib. Okay, and for this pyplot, it provides a number of functions to create plots, and we can also customize the plot features. Okay, so here it gives us a very simple one. So you need to specify, you see, you need to calculate the X, Y coordinates, and then you just call the plot method, but you need to plug in the X, Y coordinates. So this is different, okay, from pandas, we will see. But over here, for this plot, you can also customize like label, title, and plus some other features, okay. So that's why we say it's rich and it's more complex for us to configure the plotting area itself. So one of the major advantage for matplotlib is it provide we call it a configurable canvas. Okay, and there is a function called figure. So this function to returns the figure object. If you recall previously, we mentioned that matplotlib is object oriented. So object oriented, so that's why over here it mentions a figure object, okay? And because it has a figure object, so you can add subplots to the canvas. So it's kind of, it provides, so this figure, so this is a figure object, okay? It's a canvas. So then on this canvas, you can add a subplot, so you can provide, so those are considered subplots. So you can provide some subplots. So subplots, you can use this add subplot method to add onto the canvas. For pandas, it doesn't have this functionality. So no canvas, no subplots. Okay, so it just create a chart or uh, um, a plot. Okay. And then it says various plot, so you can create on it like the line or scatter or bar, okay, or like a KDV distribution something, okay. So you see, so for the matplot, you can place various plot like on one canvas, okay. So you can arrange multiple subplots on one canvas. And on top of that, for each subplots, it also provides us beside like the data display. So this is the essential part. Okay. So Pandas also provide this data display that, but it also provide us like you can do label, title, grade line, legend, annotation. Okay, so very rich. Okay, for your plot. So for each it has a respective method to do that, and we will uh, see that in our examples. And there is another approach is we can integrate. Okay, so you can combine the plot method from Pandas, and also you can configure the plotting area from Matplotlib. So we can also integrate both together. Okay. So for Pandas plot, so it in this Pandas plot method, it has the argument. So for the argument, then you can specify the plotting for the subplot. So you can specify the subplot for your chart or for your like the curve or the line. And the subplot can be created with Matplotlib's subplot method or add subplot method. Okay. Then in this case, like the previous slide I explained, it allows multiple plots shown on the same panel, okay, on one panel. So because previously, if you just use Panda, you cannot achieve this multiple plots on same panel, okay. But if we integrate both together, then you can plot multiple subplots and let all of them display on the same canvas. So then in this case, it's kind of we can take advantage of the best of both. And here it also gives us a comparison, okay, between Pandas plot and Matplotlib's plot method. So Pandas plot method, it belongs to data frame, okay. So because it's come from data frame, so it understands data frame structure, and it says it can automatically extract. So this is a nice part, okay. So it can automatically extract data for plotting, okay, and based on column names. And for Matplotlib, it doesn't understand data frame because it's purely based on X, Y coordinates. Okay. So the plotting need X, Y coordinate value from us. So we need to provide that. And the second difference is for the plot method from Pandas, it offers basic and quick approach to do the EDA. Okay, so exploratory data analysis through visualization. Okay, And for Matplotlib, because it has more features, so it offers more complex and customized features for the plot. So if you want to have a rich one, then you can choose Matplotlib. But because it's rich and informative and complex, is it? So it's also regarding the coding for Matplotlib, it's more complex compared with Pandas. Okay. We will just stop here. Okay. And let's move to our coding part. Uh, so our first example started from Yahoo Finance. We download 4 ticker data. Okay, download for 3 months between last April to last June. Because I wrote this example during last summer. And yesterday when I checked, looks like the Yahoo Finance updated. Okay, so when I wrote, I use Yahoo Finance, the version is 2.41. Okay, now they updated to 2.54. So if you run my textbook example, it may report error. Okay, if you are not using this version, if you download with the latest one. Okay, and also for the data here shows the download, the result is multi-index, so it's a hierarchical one. Previously, when I wrote this example, what this returns is not a multi-index hierarchical data frame. Okay, so it's just involve one level, and the hierarchical multi it involves multiple levels. If you recall previously, we learned. Okay, so what I did is. I tried with the new one. Not this one. Got it wrong. I tried with the new one today. Okay, so let's first take a look here. Okay, then go back to my example so it can help us understand better. So here we do the download and specify each ticker. Okay, for each ticker is a different data frame, and you also specify the range. Okay, so here we have 4 data frame. And then we call the concat method. If you recall, last class we discussed you can pandas allow us to have multiple data frame combined together. Okay, we discussed 3 approach. So concat is the one method. Concat it allows both vertical and horizontal stacking. So that's concat. We also learned the second method, merge, if you recall. The merge method, so it use column, matching column. Column to do the merge. Okay, we also learn join. Join, it's uh, also allow both from like allow the merge, allow a merge on both axes. So row and column. Okay, so that's what, so over here we just use concat, okay, from pandas. So then you specify the data frame in a list. You also specify when they do stacking, they stacking vertically or horizontally. Is it over here? It's horizontally, okay, not vertically. And because the data originally from Yahoo Finance downloaded, what it looks like, it's kind of like they have close. So the hierarchical, they have close price, open price, something, and volume. And then they have ticker like TSLA, TSLA. Okay, for each of them, they have that TSLA. So, and then they have the data is like suppose 150.9, 395.9, something, something like that. Okay, so that's why, because here for each column, so this is column. For each column, we see there are two levels. Okay, so that's why we see this is a hierarchical. Hierarchical for the column, okay, and the multi-index, or we call it multi-index. So the data frame is hierarchical and multi-index, but only for color, okay, in this case. And because it's originally arranged like this, okay, the outer level, so we call this level. This basically level is 0, okay, and here level is 1, okay. So the outer level it's the price and the volume. The inner level it's the ticker. And normally we like reverse. Okay, so there is a function on pandas. In pandas, it's called swap level. Then you specify which axis. Okay, then in this case, then it will swap the level. Okay, so after swap, so we do this. It's also consistent with our with the example in textbook. Okay, so then we can take a look at the top 5 records and also find the index. Okay, so let's take a look at the result so that it help us understand. So what it looks like after we do the swap level, did you see? So this is a column name. Okay, this two. So the outer one is named as ticker, the inner one named price. And so the outer, then it has the ticker, okay, for the level. So this is level 0, okay. And this is level 1. Level 1. So level 1 that has a close price, open price, and the volume. So over here for each ticker, okay, because we concatenate the 4 data frame together. Okay, so this is, and these two are the name. So names for column, for the 2 level of columns, okay. And I will post this example to the GitHub, okay, so that we can keep track of that. Okay, then let's go back to the old version example. Okay, so for the old version, you can see it. Then it involves more work because it's not a hierarchical. Okay, so the old one doesn't have a ticker. So for each one, it just has an open close price. Okay, if you recall in the previous chapter. Okay, and because of that, it also try to change the column name. So for Pandas data frame, you can rename the column, okay, called the rename function. So that's what this part does. So for the price and the volume, so we each have 4 data frames. And here, same thing, they call the concat, okay? But this is not the hierarchical one, okay? And because over here we have multiple different ticker, so we combine all of them into a one data frame. So that's why over here we try to build a hierarchical index, okay, with a multi-index. So the way to do it in Pandas, there is a function, then you can call the multi-index and from tuple. And then over here, you provide the true level of the column name for each column, okay, and then assign it to the column. So you can see it's more work compared with the new one. The new one is already taken care. You don't need to do that. So after that, then we can check the first 5 records. So you see the result. Okay, because over here we pick out only the close price and the volume. We only pick those 2 column. Okay, so over here then we see the ticker and the price and the volume. So that's this data frame information, okay? It's all from the previous chapter. Then next, let's see. And over here, we learn another new function called XS. So this is cross section. It does cross section for data frame. For data frame, if you recall, previously we learned different approach to do indexing and slicing. If you recall, for Pandas data frame. So if you have a data frame called DF, is it you can do the square brackets, is it? And you can do the index and the slicing directly. So this is one option, but you remember you can only pass in column. It doesn't apply to row, okay, with the direct way. And then if you also want to, it allow you do the indexing and slicing on row, then we have the dot lock method and the dot I lock method, if you recall, is it? And for this, so this will allow us for both column and row. Now both column and row. Okay, and for dot log, if you recall, it's label. You can use label name. And for dot ilog, you need to use number. So number for the position. So that's the second option. The third option is the data at and the data I at. Okay. So today there's a new one called XS. And for this XS, it's a cross section. And this XS, it's more convenient, so apply better to hierarchical indexing. Hierarchical or multi-indexing. Indexing data frame. Because if you use .lock, .iloc, it may be more complicated, okay? But with the access, it's very straightforward. So you specify, so we call this as a key. Okay, key can be the labels, okay, and it can be the single, like a label can also be a tuple, okay, so you can provide multiple columns. And you can also specify its column, axis is 1 or axis is 0. Also specify which level, okay. So here it says level 1, okay, so the inner level. So just get the price and the volume, okay. So then, so this part is try to get the section or subsection of the data, okay. So just like what we do previously. So it does indexing and slicing, okay. After that, you can directly call the plot method. You see here, we directly call the plot method. And for the plot method on Pandas, it's directly on the data frame. Okay, so this plot method is from the data frame. But you need to specify what kind of chart or graph you want. So in this case, we say, okay, we want a line graph. Okay, what line graph provide us is it provide you the trend for continuous data. Okay, so in this case, we want to know the trend for each stock ticker's continuous price. Okay, and the same thing for the volume. So if you wanted to know the trend, then you can pick the line to let it give you the graph. Okay. And so we call the plot, and then let's take a look at the result, what it looks like. So if you take a look, the first is regarding the price. We didn't specify, so this is called the title part. Title, okay. So over here it's the label, so X label and Y label. It provides, okay. It also says, okay, it's the daytime. That's it. And this part is called legend. We didn't specify all of this. It's just come default, okay, because you just specify the kind. Oh, the title we specify, okay. And here there are 4 tickers, so it provide 4 curves, okay, and it also reviews the trend, okay. So the distribution, you can see the data distribution change with the time, okay. And for volume, it's similar, is it? But if you take a look, the volumes, the legend, it is placed at a different location, okay? So by default, it will pick the best place so that it won't overlap with your graph. And also take a look, so by default, because the volume is a large number, is that? So that's why with all of the zeros, it will not show the number with all of the zeros. So it will just show it by default as the E8. Okay. Okay, for the next, what we are going to do, we still select the price first. Then this time we do the mean. So this mean is for each ticker. So each ticker for the 3 months of the stock closing price, we are going to find their mean price. And same thing for the volume, we are going to find their summation, volume summation, okay? And we also, so here it also gives the output of those information. Yeah, you see from the data frame, definitely you can see the data is it, but it didn't show us some more information is it. And this time what we wanted to do is we want to do some comparison is it among the 4 different stock. So that's why this time when we do the plot, so first we use the mean price among the 4 different different tickers, okay? So this time the plot is bar, the kind is bar, okay? So for bar, if you recall, it's emphasized on comparison among different items because we have these 4 different ticker, etc. So we choose the bar and for the average price, and we can kind of get some idea. Okay, looks like, okay, NVIDIA compared with the other is not that high. Okay. And similar, you see, for the volume, okay, we also do the bar, okay? And you can also specify the color, okay? And so among these 4 tickers and their volume comparison, etc., and we can clearly see it's because this is for comparison. So bar reviews comparison. Previously, we learned line. Is it line is more for trend and continuous data. And this bar, and for bar, you see the comparison is very obvious. Is it all NVIDIA, the transaction volume is much higher than the remaining. Okay. So we can kind of also say, oh, it's a hot pick, is it, for NVIDIA during those time period. Okay, so that's regarding bar. And what next one? Let's see. So this time it's about the histogram. Okay, so this is histogram. It's still regarding closing price. So histogram, so it reviews the distribution. It's about frequency distribution. Okay, so what here we do, so the x coordinates is the price, and the y coordinates it's frequency, so the number of items. Okay, and for histogram, for this history, we also divide the range, the price range to 20 bins. Okay, 20 bins, and then for each bin, so we have 3 months daily stock price. So with that, is it then you can count, okay, like between certain ranges that like this media is 80, maybe the next one. So here is 100. So maybe over here it's 85, something like that. Is that so? Within each, so each of this is a bin. So within each of this bin, so how many days? So the number of days, the price range is in this range. It will review you some of this kind of information, is it for all these four different stock picker. Okay, so histogram, it provides the distribution. So it's a frequency distribution. Okay, so it's even though it looks like a bar, it's not a bar. Okay, this is called a histogram. So bar is for comparison. The histogram, this is for frequency distribution. So be careful about the difference. Okay, then if you recall previously, we also discussed for distribution, there are two items. One is a histogram, or you can do box. Okay, so here, same thing for the volume, we are going to plot as box. Okay, so the result looks like this. So for each stock ticker, you have something looks like this. So this kind of, we call it a box and whisker. Okay, and so what does this mean? And here is the exact volume number, is it? And for histogram, it's the frequency distribution. So you count the number of items fall within each bin, is it? And for the box, it's also about distribution, but it's different, okay? So over here, you will see each of this, we have a box. So we call this box. And then we have this whisker, okay? So what this box? And you also have some line here, is it? So basically, for this box, what it reveals is this upper one. This is the 75 percentage quantile. If you recall previously for data frame, we have that describe function, if you recall. And the describe give you statistics, some basic statistic data, is it? And within that, you have minimum, you have maximum, you have the 25 percentage quantile, 50, and 75, if you recall, as they give you those data. So it's something like that, 75 percentage quantile. This is 25 percentage quantile. So below it, it's below 25. Up it's above 75. Okay, so this middle is middle 50 percentage. So this is the media percentage, the quantile. Okay, and so what is this whisker? So this part of whisker, then it's 1.5. So this range, the 50 percentage, we call it inter quantile range. Okay, so then this going to be 1.5 inter quantile range of the 75 percentage. Okay, and for this whisk, it's the 1.5. The interquantile range is of the 25%. And beyond that, you see, we also have some dots. Is it so? This considered outliers. Okay, and you can also see the media is not necessary to be in the right middle of the 50%. No, okay. So it depends. If it's not right in the middle, so then that means the data has some skewness toward one end or the other. Okay. And we can also see the box, the height of the box is different, is it? So for the box, basically, the taller it is, the more um, uh, it's more kind of the data distributed more with more data range. Okay, not like it's more close to each other. Okay, so that's about the box um, plot. So the box plot, you can, after this explanation, we can see it also reflects distribution, is it? But this distribution is more reflect the different quantiles distribution. So it's not about frequency distribution, okay? So you can choose when you want to see the distribution. You want frequency count or you want the different quantiles, the distribution. Okay, then you can pick either histogram or box. Okay, then next, let's take a look. So what next we are going to do is here we also do plot. But this time, if you take a look, we also specify X and Y values. Yeah. So the type of the plot, this time it's scattered. If you recall, previously we discussed, we said scatter, it's reflect different data's correlation. So it's reflect data's correlation, okay? So let's take a look. Over here it says, okay, for the X value, it's Tesla's closing price. And the Y value, it's NVIDIA's closing price, okay? So that's the first one. So then here is the plot. So the X coordinates is Tesla's closing price, and the Y coordinate is NVIDIA's. So both are regarding their respective price, is it? So then for each dot, then it's a price, okay, happens here, is it? You have Teslas and you also have NVIDIA's. So it's kind of reflect some correlation or the cluster distribution, the clusters or data clusters. And in later chapter, when we do data modeling, we will also learn the clustering method, okay? And also from what here we did is for each pair, we do the plot. And then they have their individual plot. And they all, you see, each one has their own plot. Okay. And later on, we will see if we use matplotlib, we can put them, this group of plot together. But for pandas, you cannot do that. So each one is their own plot and in their own plotting area panel. Okay. So that's regarding scattered. For the next one, its plot type is area. So this time we are going to do the closing price. Okay, do the area plotting. So for the area plotting, if you recall what it can reflect each one's own trend because there are parts of it. It's the line type of graph, is it? But on the same time, it also reflects the cumulative total. Yeah. So all this four together, is it cumulative together through the 3 months and their totals? Because the area, then you can just do like integration, as a calculus integration, you can find the total. And also we can see for each stock ticker, it's a different color. So in this case, it's also reflect each stock's contribution to the overall. Okay, so it reveals quite information. Okay, with area plotting. And for the next one is regarding volume. Okay, and this time we are not going to do daily. Okay, so we resample as monthly. So for each month, so basically we take 3 months. Okay, so we should have 3 results, and we do the summation for each of the months. Okay, and then it's still bar plotting, but this is a horizontal bar. Horizontal bar. And if you recall, bar is for comparison. It can clearly see over here, as it for each month, it has 4 different tickers. Each month, a different 4 tickers. So for each month, it has comparison, and it also compare among different months, is it? And clearly, we can also see is it NVIDIA is a quite active traded ticker. And over here, we still working on the volume, but this time we do the summation, okay, for each ticker for all of their days. And when we do plot, we choose pi. So what does this do? And also here, it also provide how you format the percentage, okay. And so it's pi. So what pi reflect is the each one's proportion in the overall contribution. Okay, so it's very obvious with the pie plot. Okay, the contribution. And if you recall, for the area one, it also reveals, but not as obvious as a pi. So if you just want to reflect the each category, each class's proportion to the overall contribution, then you can choose the pie plot. We are going to skip this because that's more mass plot lib stuff. Okay, the next one is about that KDE. Okay, so that's kernel density. E is estimation. Kernel density estimation, okay, from statistic class, you know what it means, okay. And it's about the distribution, okay? If you recall previously, we learned that histogram is also about distribution. So it's a frequency distribution. Okay. And we also learned the box. And the box, it's more quantile distribution. And for this distribution, it is a likelihood distribution within certain range. Certain range you can specify. Okay. Yeah, so there's subtle difference. Basically, the KDE, we can also think of KDE is a kind of a smooth version of histogram. Okay. You can also think of it like that. But it's not, okay? It's about the likelihood. That's about frequency. So let's see what the diagram looks like then in this case. Okay, so here for each of the ticker, it is, so this is price. And here is the density, okay, the density. And so for this is the videos, is it? And if you recall from math, is it? So kind of like, okay, so here's 100, is it? So if you want to know the likelihood that this is regarding volume or regarding closing price. So the price fall within this range, they specify within this range, then you can do the calculus integration, the area under this will be the likelihood, okay, the possibility, okay. And we can also see if the curve is more high, that so the peak point is more high, then the more possibility that the price will be in that range, okay. And if you integrate all of that, the possibility will always, the likelihood will always integrate to 1. So the area is always 1. Okay. So it gave us this kind of idea. So this is about KDE, okay, kernel density distribution. And let's take a look at the next one. We are also going to learn some new concept about pandas, okay, from Panda. So this part, we are going to still doing the closing price. So this is a data frame, what it will return. And for the data frame, we have a function called differ, okay. So what this means, if you recall the closing price, it has a day 1, a day 2, a day 3, something like this, okay, following. So the 3 months, each day's closing price, close price, is it? So the differ is trying to calculate the difference. So it's the second day minus the first day, okay. So here is the differ. So you will have some value, but the first day it doesn't have any compare. So normally it is filled with none, okay. And for all of the remaining, you have the price difference calculated. And over here, we then call a function called apply map. If you recall, in Pandas, we also learned the apply method and the map method. If you recall, for the apply, if you recall, it's for row, for some row or some column. So row-wise, we can also see either row-wise or column-wise. Is it? And then you can apply some specified operation. Okay. For map is for series. Okay. And here the apply map. So then it's different. Okay. It's not row or column-wise. This is element-wise. Okay, so it's an element. If you recall NumPy, we mentioned one of the features element-wise operation that, yeah, and the pandas is similar. So over here for this apply map, then this operation will be element-wise. So each element of the data frame will be checked against this operation, okay? And so then what it means here, this operation, okay, if the price is positive, then it will assign increase the string. Otherwise, you assign decrease to the value, okay? And then for this day of week, the index, we also going to kind of rename it. Okay, not using the specific day 1, day 2. We are going to use like Monday, Tuesday, Wednesday, something like this, Thursday and Friday. Okay, we use a specific day. Okay, so that's what this part does. Okay, these two line of code. And then over here, we do another function. It's called cross tab from pandas apply to certain data frame. Okay, and what the cross tab does is it will apply for each of the stock ticker, is it? And it also specifies row name and column name. Okay, so it's based on this data that we just come up. So the data will only have increase and decrease. Okay, so basically what it will give you is, let's take a look at the result. Okay, then to help us understand better. If we take a look at the result, you will see for each ticker, it gives you something looks like this. So this is a result of that cross tab function call, okay? So it will give you the increase, decrease, and the day. So basically, the number of days that it increase, number of days is decrease. Give us this kind of information, okay, for each of the ticker. So then what we are going to do is this time we wanted to do horizontal bar, okay? We want to see some comparison, okay, about the increase and decrease between the different stock ticker. Then, so over here, the cross tab. So for the plotting of the cross tab, so we first for the Tesla, for this ticker, okay, then for each of the day, and the number of increase and decrease. And also over here, the increase and decrease also stacked. with different color. Okay, so then you can clearly see is it which day has the most increase and which day has the most decrease. Okay, so it will give us like this kind of information with the horizontal bar. Okay, so over here it's the comparison. So this time the comparison is not among different tickers. So it's a comparison among different weekdays. Okay, and we also stack together increase and decrease. And we use the horizontal bar, okay. And to allow two different value stack together, then you set the stack as true, okay, for the bar. And for vertical bar, you can also do that. It's similar. So here it shows the horizontal bar, okay. Let's see if we have any. Oh, the next one is regarding matplotlib. And I think we cover plenty of information today, okay? So we are going to stop here for pandas plotting. And the next class, we are going to discuss matplotlib.